horizontal and vertical transformations in Algebra 2. The only difference is we are going to be applying it to more than the functions that we originally did. So if I'm looking at transformations, what causes the graph to move up or down? Okay, the y-intercept, if you add or subtract something on the end. So vertical shifting. Okay, if you have f of x plus c, so if you add something on the end, that moves it up. If you have f of x minus c, that moves it down. Okay, so make yourself a little note. You don't have to write that whole thing, but maybe the two pieces I underlined. If you have a function plus a number, you move up. A function minus your number, you move down. Outside your function, changes y, does what you think. Positive up, negative down. When we graph these, I am going to expect you to graph a parent function, which would be one of those functions that we've been looking at the past 2 days, and the transformation. Your parent function will be a dashed line when you graph it, and your final transformation will be solid. That way I know the difference between the two. I am also going to say that you have to have a minimum of 3 exact points on each graph. So I don't just expect, I'm not just wanting a parabola and something like this. I want some exact points when we go to graph these things. So we are going to graph x cubed and x cubed plus 4. Alright, what does x cubed look like? X squared is a parabola. X cubed is like the chair. Alright, let's get some exact points. 0 cubed is 0, 1 cubed, 2 cubed. You can't hardly see. Okay, negative 1 to the third is negative 1, negative 2 to the third is negative 8. So that is my original. I'm just going to make that dash. Okay, x cubed plus 4. What will this plus 4 do? So I expect you to take at least 3 of these points and shift them up 4. Then we'll draw that as our solid one. Any questions on that? What would the domain and range be of that final graph? Infinity, positive infinity. Okay. I want you guys to do one. So graph the parent function and the final transformation. There's yours. So absolute value is your b. Exact points, so maybe 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2, negative 3, 3. So minimum of 3. If all you have is 0, 0, I will count it wrong. Just so you're warned. What's going to happen on this one? Down 2. So take each of those points, shift them down. Again, not just a single point, minimum of 3. And make sure either do solid and dashed or label which graph is which. Alright, up and down okay? What causes the graph to move left or right? If it's in front, if it's multiplied, that stretches and shrinks.
Wasn't it like parentheses?
Yeah. If you have something inside the parentheses, if it's attached to the x. So you don't have to write down this whole thing, maybe these two underlined pieces. Outside is y, does what you think. Inside is x, it does the opposite. So if I subtract, that actually moves it in the positive direction. So if you subtract on the inside, that goes right. If you add on the inside, it's going to take it in the negative direction, and it's going to go left. So inside is x, it does the opposite of what you think. Yeah, you've done a little bit the past few years. I'm going to do a couple with you, and then I'm going to give you guys some problems to work. You guys have what you need? So my parent function here is x squared. What's x squared look like? Right. 0 squared is 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. Does everybody know, when I'm graphing these parent functions, do you guys know how I'm getting my exact points? Yep, just a t-chart, and I'm just too lazy to write it down. So, all right. I'm asking you to do two different things here. G of x minus 3 means you are going to do x minus 3 squared. Inside is x, and it does the opposite. So subtracting 3 would move it right. So I'm going to take each of those points right. The next one was g of x plus 2, so that means x plus 2 squared. So if I add to x, that's going to take it left. 2. So it's back to the original, and you're moving all of those left 2. So, okay with everybody? So now that we've talked about the different types, if it's inside the parentheses or inside the absolute values, that's x. If it's on the end, it's y. I'm going to put 4 problems up here, and I want you to do each of them. So figure out what the transformation is and draw a quick sketch for each. And then I think I'm probably going to call people up here to do it on the board. Something different. You guys get tired of me talking? You want to be the teacher for a while? Okay, here's a few to try. So first one, took your parabola and moved every point up 1. Okay, so any volunteers for B? Okay. I have a random number generator here. It generated number 10. So the 10th person, alphabetical order is Lauren. So you get 8. Alright, so parent function is again, yep,
That's fine if you just do 1, 1, 2, 4.
you need some negatives too.
Well, I know that, but like, oh, yeah, for property you can make.
Well, you have to have both sides of the
So
parabola.
yeah,
Okay.
you said we needed 3 points.
Yeah. So she's got her parent function. Now, what's going to happen this time?
In the parentheses, that's like right.
Yep. It's inside, it's attached to x, does the opposite of what we think, so it'll go right one. Very good. Okay, next up, number 12 is Dalton.
On C.
Yeah. So, parent function this time? Here, we can scroll up.
Oh, you're fine.
Still x squared, so still a parabola.
If I can do this right without it looking. That looks like a V.
So now what's going to happen?
It's gonna go left 3.
Left 3. All right, perfect. Last up, number 9 is Rachel. So this one is a different parent function. It's got x cubed, so it's your chair, yeah. So 0 cubed 0, 1 cubed is 1, 2 cubed is 8. I think that might be at 7. We're going to do, once we do all the transformations, we're going to do some paper assignments too.
You all got some good dashes. Mine is like that. Mine is.
All right, so this one, what's our transformation?
That's 4.
It's outside, it's on the end, so it will go
Down 4.
down 4. It's not inside the parentheses, so it's moving down.
Wait, we're not just on transformations?
We're going to start stretching
Next week.
Monday.
Way to start the week off bad.
That's not bad.
Now you can move on.
Yeah, that's right. I agree with you. That's always
Yeah, we do that.
different.
We just have a test, Tuesday.
No,
and
definitely
Thursday.
not. No, we should not.
I mean, I'm fine with that. You are.
All right,
Well,
good.
that's the way it is, the better.
Any questions about these? Those are going okay? All right, so let's say I'm going to give you a graph. And we're going to go backwards. I'm going to give you the graph, and we're going to write the equation to go with the graph that I gave you.
Okay.
All right, so first of all, you have to recognize what the function is.
Absolutely.
This is an absolute value. So we have the absolute value. Okay, how did this move the normal absolute value? It went right 4, correct? Because normally an absolute value would look like this. So what would make it move right?
X minus 4.
X minus 4 on the inside. Okay. B. Still an absolute value. We know normally our absolute value would look like this. So this took our absolute value left 2. X plus 2 inside our absolute values. add to X, go left. The inside is X, it does the opposite, so when you add, it moves it in the negative direction. Okay, C.
See value outside of ours minus two.
Right. That one is still absolute value, but it moved it up, or sorry, down. So, outside is Y, and it does what you think. So it'd be an absolute value of X with a minus 2 on the end. So it moved it
I have
down.
a
Yes.
question. Why is that yellow thing been like moving along the screen like this whole time? Like the whole
The
time? Does it
recording.
bother
It's
me?
kind of annoying. Yeah, it's the recording. I didn't get my window wide enough so you could see the border. Usually I try to make it wider so you don't see that.
Another one is absolute value plus one.
Alright, D is still absolute value, but it went up, so plus 1.
You're freaking genius.
Okay.
Does that make us, or random, or like, random like parentheses, and like say it was right for, let's do like X,
Yeah,
X minus, or,
just like that would be
yeah.
fine. Okay,
Who put Y to that?
last little bit thing. I'm going to give you some problems. We are going to find our transformations as well as give domains and ranges, just for some practice. So you can have more than one transformation in a problem. So I took this one. I'm going to start with my absolute value function. Okay, then we know absolute value is going to look like this. I asked you to describe the transformation. So what does this plus 2 do? What's the minus 6 do?
Down 6.
Okay, so for each point I have, I'm going to go left and down. So left 2, down 6. For all of my points. Okay. What would the domain of this function be? Goes left and right forever, negative infinity to infinity. What is the range of this one?
Bracket 6.
Bracket negative 6, comma infinity. Starts at negative 6 and goes up forever. Alright.
Should we go off the, not the dotted line, but the,
Yes, your final one. Okay, last example. So what's my parent function this time? We've got our x cubed, so that's the chair. 0 cubed is 0, 1 cubed is 1, negative 1 cubed is negative 1. Describe the transformation. So, inside that would go right 1
4.
and up 4. Okay, so far so good? So I'm going to do that on my graph. So go right and up for each of these. Here's my new one. What is the domain of this? What is your range? the homework is going to sometimes ask you, just give you an equation and ask you for the domain of range from that equation. So all you need to do is draw your quick sketch of the transformation and then look at that graph and answer the question. Alright, any issues with this stuff?
No, ma'am.
Okay, so you have a Math Excel assignment.